The plasma membrane. A wall around the cell, every molecule locked in place.
That's not a wall. It's not even a solid. It's a liquid, a two-dimensional liquid, and everything in it is drifting.
3 ways this topic takes marks off you. 3 minutes to kill, all 3. Start with one molecule, the phospholipid, a head and 2 tails. The head is phosphate, polar, charged. Water bonds to it happily, hydrophilic. The tails are plain hydrocarbon, no charge, nothing to grab. Water wants nothing to do with them. One molecule, 2 opposite demands. That's amphipathic, and it can't satisfy both alone. Now put it where it lives. A cell is water on the outside, water on the inside. The heads chase water, and water is in 2 places, so the sheet doubles. Heads out, tails sealed in. Draw it the other way, tails facing the water, and the water tears it apart. One single layer can't work either. One of its faces always loses. 2 leaflets, tail to tail. Not the best of several options. The only one. So why do the tails clump? Ask a class and you'll hear, the tails attract each other. They do, faintly. But that is not the force that built your cell. Watch the water instead. It can't bond to a bare tail, so it cages it. Locked, ordered, expensive. Push the tails together and the cages shatter. Most of that trapped water goes free. The membrane didn't assemble itself. Water assembled it. Same force that buries a protein's core. Look what that produced. A band of pure oil running down the middle of the sheet. Small and nonpolar, oxygen strolls through. The core is no obstacle to oil. But a charged ion would have to strip off its water shell first. It just doesn't happen. The membrane isn't strong, it's greasy. That's a completely different kind of barrier. So everything else needs a protein, a doorway the cell can open, close, and control. The model has a name, and both words are load-bearing. Start with fluid. Nothing is bolted down. Lipids swap places millions of times a second. Proteins wander. A rigid membrane couldn't do this. Take in a vesicle and fold it straight into the sheet. It couldn't reseal a puncture either, or bend, or let a cell divide. Movement isn't damage here, it's the job. Though flipping across the layers, that's rare. Now the second word, mosaic. And every piece sits where its own chemistry puts it. Proteins that span the sheet are amphipathic too. Oily waste in the core, water-loving ends out. Others rest on one face. Sugar chains face outward, always outward, the cell's ID card. One problem with the liquid: heat it and it goes runny. Cool it and it seizes solid. Cholesterol fixes both. Hot, it restrains the tails. Cold, it props them apart. It's a thermostat, not a dial. It resists change whichever way the temperature pushes. One chain, start to finish. Amphipathic, water on both sides. Bilayer, oily core, barrier. So, it is not a wall. The heads face out, never in. And nothing here is decorative. Water built this membrane, and water is the thing it keeps out. Want to step through this one yourself? Links below.